Now and again in a trilogy of films they decide to make another one or even a whole bunch of other ones after the main three. I mean, this is quite rare. Typically they become terrible, but sometimes, well, actually I can't think of any cases, but I'm sure they exist. Like the fourth or fifth film might actually be incredible or just a different sort of take on the film franchise. Well, today we're going to have that, but with partial fractions. So we've done 3 lessons in our trilogy, and we looked at 3 different cases, which I'm not going to go into detail on now, but you should think about what those are. And today we're going to just take a little bit of a spin on it, because if you think about it, we've been doing lessons on the binomial expansion. So how can we incorporate partial fractions into that? Well, that's coming up. But first, here's a bit of a question that I'm going to pose. When I wrote this title, I used an exclamation mark because I just thought I want to emphasize that they're back, which made me think back to quite a common sort of pub quiz question you get in the UK, which is as follows. For one, actually, you're not given cool points, but I'm giving you cool points here. For 1 cool point, answer the following question. There's one and only one town in the UK which has an exclamation mark at the end of its name. Can you name it? Try not to look it up. If you know it, then let me know, okay? If you don't know it, then alright, look it up for your own interest, and then let me know that you looked it up. See if you can get 1 cool point there. I'll give you half a cool point if you look it up and tell me. Right, second question. Can you name any other towns around the world that you know of that end in an exclamation mark? I found one other myself after a brief search, but I'm sure there are others. So how many cool points can you get from this little starter? Alright, onwards with some maths. So to start with, I've got another starter question for you, and it's just recapping recent lessons basically. Let's see how you deal with it. This is actually from an old past paper from an old A-level syllabus, but it's the sort of thing that you might need to deal with, and it's a bit of fun to start with. So pause the video and have a go now. Okay, I'm going to go through this. So actually I don't have the formula right in front of me, so I'm gonna write it down. I know that 1 plus x to the n, and this is something that's worth learning, is 1 plus nx plus n minus 1 over 2 x squared plus dot dot dot. Okay, I know it's an infinite series, and in the formula they give the rth term, but I've got the starting point, that's all I need. So I'm ready to tackle part 1. 1 plus 2x to the half. Okay, the only difference here is that instead of x, I've got 2x, but as we said, we just replace all our x's with 2x. So that's going to be 1 plus a half times 2x plus a half minus 1, which is minus a half, divided by 2, and then 2x squared, all in brackets, plus a half times minus a half times minus 3 over 2. Again, I just minus 1 from it. You should know your fractions well to be able to do this. Divided by 3 factorial, or 3 times 2. I'm going to write it as 2x cubed. And that's all I need to go up to x cubed. But I do need to simplify it now. So let's have a go at that. I'm just going to start crossing things off. So I know that the half is going to cross off with the 2. And I can start writing down the answer. It's going to be 1 plus x. What's going to happen next? Well, I'm going to get a 4x squared here, so I'm going to immediately just cancel out that 2 with 2 of these halves, and that's going to leave me a minus and a divided by 2, so it's going to be minus a half x squared. And on this final one, I can see the 3 is going to cancel with that 3. This 2 I'm going to cube to give me an 8, so I'm going to cancel that out and then cross off this one, and this one. I'm left with a minus a half, and I'm left with a negative here, so it's going to become positive a half x cubed. Of course, you can use your calculator for that, but hopefully that makes sense. And that's all good, 3 marks. Not too bad, not too much effort needed there. Okay, question part 2. Hence find the expansion of this thing here as a series in ascending powers of x up to and including the term in x cubed. This really is a test of our last lesson, except that it's still just only a 1 plus whatever. But it's making me think, how am I going to deal with this when I've got a fraction? And the answer is that we need to write this as it was, but then we need to bring this up. So 1 plus x to the minus 3. And over here, I'm going to now find out what 1 plus x to the minus 3 is. So this one's, because I've not got the 2 in there, is actually a little bit simpler. So it's going to be 1 minus 3x, because that's my plus nx. And then I'm going to add minus 3 times minus 4 over 2 x squared, and then I'm going to add minus 3 times minus 4 times minus 5 all over 3 times 2. I could write 3 factorial, but I can cancel it out more quickly if I start writing it like this. Right, let's check it out. The negatives are going to cancel out here. That 2 is going to cancel out partially with the 4, so I can immediately start writing it down. It's going to be 1 minus 3x plus 3x squared. Hold on, I've made a mistake. Hopefully you spotted it. 1 minus 3x, because I've got a 3 here, but I've still got a 2. I just forgot about it when I wrote it down. So it's actually plus 6x squared. And with this final term, well, sorry, that should have been minus 4. The 3 is going to cancel with the 3. The 2 is going to cancel partially with that 4 to leave me 2. I've got a triple negative, so it's going to be minus 10x cubed. Okay, bit of effort, and you can see why this is 5 marks, because we're not done yet. Now I've got a binomial expansion that I've already worked out, but then I've got another binomial expansion that I've just found, and actually I've just realised there's no way, not enough space at all, have I? Right, I'm going to make space, because I'm going to imagine that you've understood that, understood all this working, and we can simply write this down, but obviously you need to show you're working. Okay, brilliant, we've got space now, that can go. So, imagine that's just in the corner over here. That means I can write down that this thing is equal. So now I'm going to need to write down my first expansion, 1 plus x minus a half x squared plus a half x cubed, and I'm going to multiply that by 1 minus 3x plus 6x squared minus 10x cubed. Remember back to those days when you were just like struggling for the first time to multiply double brackets, and now we're doing stuff like this, and technically this is an infinite series, we've just truncated it. And we want the expansion of this up to x cubed, so I don't need any other terms. The questions led me along this way, but I do need these x cubed terms. Now we're going to very carefully think about how we get each term. I mean, I could, okay, the old school way of doing it is to multiply every term by 1 on the right, then every term by x, and then every term by minus a half x squared, and try and put it all together. But you're going to end up getting terms you don't need, like an x to the 4 when you multiply the x squareds. So we're going to do it in a more clever way. We're just going to take each bit in turn. So how am I going to get my constant term? Well, the only way I can get it is by doing 1 times 1. How am I going to get my x term? Well, there's a few ways. I can either do 1 times minus 3x, or I can do x times 1, and that's it. How am I going to get my x squared term? It's going to be more this time. I can do 1 times 6x squared, or I can do minus a half x squared times 1, Or I can do x times minus 3x, which is going to be minus 3x squared. You might start thinking maybe you should just use the old school method, but you know, we've only got one more complicated bit, and really I should have left a bit of space and done some below it, but I'm trying to fit the answer all onto this screen. Okay, the last one, I'm going to do this in black pen. So we want the x cubed term. I can do 1 times minus 10x cubed. So that's going to be minus 10x cubed. I can do, okay, let's look along. Then I can do x times 6x squared. So that's going to be 6x cubed. Then I can do minus a half x squared times minus 3x, which is going to be plus 3 over 2x cubed. Sorry, that should have been a cubed as well. Or I can do a half x cubed times 1, which is going to be plus a half x cubed. And that is it. I really like the way I did the last one because I was systematic, but that's because every sort of term matched up, whereas it didn't necessarily for the other ones. But hopefully you're happy with that. Final answer then, I just need to simplify this. I'm going to get 1 minus 2x when I add the green terms. Here I'm going to get, when I do 6x squared minus 3x squared, I'm going to get 3x squared. If I then minus a half, I'm going to get 2.5, which typically we write as 5 over 2. But if you wrote 2.5, that's okay. And then the last one, well, actually it's not so bad because 3 over 2 plus a half is 2, because that's 1.5 and that's a half, so 2 plus 6x cubed is 8, minus 10x cubed is going to be minus 2x cubed. And that, whew, okay, it wasn't that, actually it was pretty bad. Right, 5 marks. And they love this little bit at the end, state the values for which expansion is valid. Now we've covered this, so the top one is going to be valid for the modulus of 2x less than 1, or the modulus of x less than a half, or minus a half less than x less than a half. I would expect to see one of these two things. Once we've done the modulus function in detail, you'll probably just go straight to this, to be honest. But for now, let's write it as this. The second one is actually the modulus of x less than 1. Okay, because I've got an x in there by itself, so it's x is between 1 and minus 1. So state the values of x for which expansion of part 2 is valid. Well, it's going to be the smallest range. It's all well and good that this bottom one is valid for x is 0.9, but that's no good because the top one is not. So you can't reliably give me the answer to the function when x is 0.9. It's like, I suppose in some sense, we've got this number line, we've got these two inequalities, we've got the one going from 1 to minus 1, and then we've got this one going from minus a half to a half. Where is the whole thing valid? Well, it's going to be where both of these inequalities are satisfied, and therefore the answer is minus a half less than x less than a half. So just be careful of that thing. I haven't spoken about it before, although I think I might have given you questions on it. So that's our starter question. Hopefully you are happy with that. We're about to get up to partial fractions. Don't you fret, it's coming up shortly. Here goes, the moment you have been waiting for. Binomial expansion combined with partial fractions. Before we do this question as an example, let's just talk about this. So actually the main point of this question is to do part B. And in parts, the starter I gave you was an expansion divided by something else. Sorry, I'm just going to take you back to it, okay, because that was such a terrible explanation. It was like, I had to do a binomial expansion and divide it, and I had another binomial expansion. I ended up multiplying them together. And when I did this, I ended up having a lot of brackets in there, and we could do it, but it was quite messy. You could do the same here, okay? If you wanted to do a binomial expansion of this fraction, you could bring the 1 plus x up and the 2 minus x up, and then you could expand those out and get, in a similar way to what we did for the starter, a cubic. The only issue is you would then have to also multiply by 4 minus 5x. So you'd be essentially multiplying 3 lots of brackets together. 2 technically are infinite series, and 1, okay, it's just 2 terms, but that just seems very, very messy, doesn't it? There is a better way, and this way is to use partial fractions. So I just wanted to talk about it a bit first, the main aim of the question. So express 4 minus 5x divided by this stuff here as partial fractions. I really want you to, if I was teaching this live in front of everyone, I think I'd give both of the starter question and this one to you to just have a go at it and see if you can figure out yourselves. Because I've taught the main bit of maths you need to do. I've taught you partial fractions, I've taught you binomial expansion, and it's really good to wrestle with these things yourselves. And even if it took a lot of the lesson or all of the lesson, then I think it'd be worthwhile rather than just watching me stand in and talking about it. Having said that, I'm gonna go through it now, but it'd be really great if you try it first and then check your answer. Here goes. Right, part A. Express this stuff in partial fractions. Okay, this is a case 1 partial fraction because there's distinct factors. So that makes it the easiest type, but there's still going to be quite a lot of effort in here in the whole question. So I can set this equal to a divided by 1 plus x plus b over 2 minus x. That's how it rolls. And then we multiply through by the denominator. I'm teaching this like you did it yesterday, but I hope you can remember it. I multiply through. When I multiply through by 1 plus x, it's going to cancel on this one. I'm going to be left with a 2 minus x at the top. Similar over here, but this is going to become b1 plus x. We can do all sorts. Remember, we can compare coefficients if we like, but nah, we don't. We do that sometimes, but we don't need to do it here. Let x equal some values. First of all, I'm going to let x equal 2 to make this one disappear, and I'm going to get 4 minus 10, which is minus 6, and that is going to equal b times 1 plus 2, 3b. So I'm going to get that b is equal to minus 2. Then let x equal to minus 1. That's going to give me 4 minus 5 times minus 1, which is 4 plus 5, or 9. And 9 is then going to equal 2 minus minus 1 is going to equal 3a, and I've got that a is equal to 3. All good. So we have, for part A, I'm just going to be a bit lazy here and write, not lazy, just to do it quickly. So it's going to actually become 3 minus 2 over 2 minus x. That's our answer. If you're doing this in an exam, you would write it below, okay? But I'm trying to be concise, let's say. All right. Hence, show that the cubic approximation of this thing is this thing on the right. How are we going to do this? Well, we're going to use our partial fractions to help us. So I can write that 4 minus 5x over 1 plus x, 2 minus x is actually identical to 3 1 plus x to the minus 1. And now I've got it in the position where I can do my binomial expansion. Minus 2 minus x to the minus 1. And this is nearly ready to have a binomial expansion on it as well. So hopefully this makes sense. We've got this function, and I just need to do 2 binomial expansions, and then I can easily add or subtract the terms. So if we think about it, I've had to do the additional step of separating into partial fractions, but then the binomial expansion becomes quite easy. If I didn't do that, then I'd have to bring this up, still do my binomial expansions, then do like this horrendous bracket multiplication. So that's why partial fractions really comes to the rescue here. Before I do my binomial expansion, I'll do them straight away. So I'm going to take each one in turn. 1, let's forget about the 3, 1 plus x to the minus 1. Okay, we can do this quickly now because we've done the starter. It's going to be 1 plus nx, so that's minus x. Then I'm going to plus minus 1 times minus 2 divided by 2x squared. And remember, in the final question, it's got an x cubed in there, so I also need that. So it's going to be plus minus 1 times minus 2 times minus 3 divided by 3 times 2, x cubed. I love this one when you've just got a 1 and x in there, because and a negative up here, because all the terms really just cancel out. It's just so quick. So this is going to cancel because I've got double negative and I've got 2. This is all going to cancel. I'll just be left with a negative. So I'm going to get 1 minus x plus x squared minus x cubed. I've got my first one done. Next one. 2 minus x to the minus 1. Hopefully you can remember how to do this. We first of all need to take that 2 out, because we know how to expand 1 plus something. So it's going to be 2, 1 minus x over 2. All of this is to the power of minus 1. So we then raise this to the power of minus 1, 2 to the minus 1, which is a half. And we've got 1 minus x over 2 to the minus 1. Maybe I should have done that first, and but just in my working, because I can see that it's going to cancel out with the 2. So but anyway, it's okay. Let's just leave the half in there. A half, and then it's going to be 1, and then it's going to be, okay, I'll take this slow, plus n x, so minus 1 minus x over 2, plus n times n minus 1 over 2 minus x over 2 squared, plus minus 1 times minus 2 times minus 3 over 3 factorial, so 3 times 2, minus, this one's just a bit more awkward, isn't it? But hey, we can deal with it, equals a half. Right, bring it together now. 1 plus x over 2. Looking at this, this is going to cancel, so it's going to be plus x squared over 4. Yep. And then loads of these can cancel. This is going to become 6, which is going to cancel with that. I'm going to get x cubed over 8, but minus x cubed over 8. I've then got another minus. It's going to become plus x cubed over 8. Okay, good. So quite a lot still to do, isn't there? This question. Okay, so obviously you don't do this normally, but I'm doing it so I can fit it all back to the original question. So these are my 2 expansions, and now I can write down that it's equal to 3, because don't forget about that 3. 3 times 1 minus x plus x squared minus x cubed, minus, don't forget about that minus, 2 times a half, okay, because I've got that half there, 1 plus x over 2 plus x squared over 4 plus x cubed over 8. Cancel these out, don't need to multiply it, and we are so close. Can you feel it? I'm going to delete that stuff at the bottom right. To be honest, you've either struggled with this question or you're probably not watching this right now, because if you got that answer, then you can be pretty sure. But maybe you're like, you're just super cool student and just watching my videos, even when you know the stuff. Okay, then I'm going to expand it out. It's going to become 3 minus 3x plus 3x squared minus 3x cubed. And then I'm just going to clear this out a little bit more. Then it's going to become minus, so I've got to multiply everything by this minus. Minus 1 minus x over 2 minus x squared over 4 minus x cubed over 8. And then I can bring this together. I think I might just go for a little breather. 3 minus 1 is going to be 2 minus 3x minus x over 2. Well, that's, I mean, you're probably putting this into your calculator at this point, aren't you? But this is going to be 6 over 2. So when I minus 6 over 2 rather, so when I minus 1 over 2x, it's going to become minus 7 over 2x. Here I've got 3x squared, and I've got here, so this is going to become 12 over 4, which I then minus an x squared over 4 from, so that's going to become plus 11 over 4x squared. And finally, I've got something over 8 here, so this is going to become 24 over 8, because that's what 3 is. It's a minus, that's a minus, so essentially I'm going to add them together, but in the negative direction. So it's going to become minus 25 over 8x cubed. And I'm right, good. Can you believe at this point they had the nerve to ask us the range of values? Like, mate, I just spent, half an hour doing this question, and for 1 mark you want me to state the range of values, do you? Okay, let's do it. So let's just look back at this, because I've lost it, haven't I? This one hasn't been expanded, but this one over here, 1 plus x, that was valid between minus 1 and 1. This is a bit of a cheeky one because it turned into 1 minus x over 2 to the minus 1. So actually what happens is that I get minus 1 is less than x over 2, which is less than 1. So actually this one is valid for a larger region, minus 2 less than x less than 2. So state the range of values for which expansion are valid. Again, it's going to be where both inequalities are satisfied, and so the answer is this one here. Okay, definitely not doing another example on that because you've seen enough. It's just a case of practicing this now, making sure that you are happy. Your algebra's got to be spot on. I've done all of these without touching a calculator. You might find that a calculator really helps you, but I think it can slow you down sometimes, but that's up to you. Just make sure that you become proficient at answering these sorts of questions, that you understand what's going on. In this question, they were sort of quite nice. They guided us through it. They said express into partial fractions and hence. You could just be given this thing here and told to do a binomial expansion. And then, you'd have to decide which route to go. The routes that I spoke about to start with, multiplying 3 brackets essentially, 2 of which are infinite series. But I know we're going to truncate them each, or writing them as partial fractions. You would have to decide. But it comes through practice, it comes through understanding. This isn't the end of partial fractions, in fact, because although this is the main teaching bit, partial fractions are going to come back in some other topics as well. It's going to be useful. Again, I'm going to leave that for now. We have seen how it can be useful when sketching and so forth. They're a fantastic tool to have, and hopefully you're happy with them. Know your 3 cases, know your binomial expansion, be able to combine it all together, and you will be in a good place with your maths, ready to look at other topics that link into it as well. Thanks for watching.